Hello class, in this video, I'm gonna go into more detail of pointers, and specifically we will talk about pointer, arithmetic, incrementing pointer, decrementing pointer, and also how you print the pointer content, which is the memory address using cout. So let's go ahead and look at the slides. I'm gonna talk about the slides a little bit, and I'm gonna switch to the coding example. So the slide basically it say that you can use pointer arithmetic, which means that you can use increment, decrement operator, or you can add, subtract value to a pointer. However, by adding, subtracting some value to pointers, they may be adding different value, not like a similar way, not the same way that you are adding, subtracting value from an integers. So I just want to point out how it works. So basically, let's say if you have a pointer that contain a memory location 4000, for example, and in regular arithmetic, if you add 2 to 4000, it should use the value of 4002, but this is not the case of a pointer arithmetic. So if your pointer contains a value of 4000, you're adding 2 to it, it means you are adding to 2 times the size of whatever the data type that the pointers point to. So for example, the integer size on my Windows laptop is 4 bytes. So if I add 2 to my pointer, so let's say my memory location is 4000, and if am adding 2 to that pointer value, I will get a value of 4008. So let's take a look at the example how that works. I know it's a confusing subject, but hopefully by running an example, you will see how it works. So let's take a look at what I have in my example. I'm declaring many different variable type: integer, double, boolean, string, and time of day is a struct variable. And I also have an array of score that contain 100 elements. And I have an integer pointer. And did you notice on line 25? What do you think? I assign the the array variable scores to my int pointer. Am I assigning the entire array of score to an integer pointer? What do you think? Well, before I answer that question, let's go ahead and take a look at how we display the memory address. So I'll give you some time to think about this. And then I assign value 10 to my score index 1. I want to find out the size of my pointer. I can also do that by using size of. You remember back in module 1 or in your previous class, you can use size of operator to tell you how many bytes of memory it takes to store some variable of a specific type. So you may wonder, what is the size of pointer, right? You can do cout size of pointer and see how many bytes it takes to store a memory address. So you can tell by the size of the integer pointer, right? Now, how do you print the memory location of all of the variable type or the variable that I declare in this example? So do you still remember what ampersand operator does? So basically, ampersand operator is address operator, right? That means it takes the address of the variable, or it tell you the address of the variable that is immediately follow the ampersand. So if I want to print the memory location of age, I just do ampersand age. Same thing with double, right? GPA, it's another variable in here. GPA, Boolean, string, I'm using the same ampersand address of operator to print. What about struct? The struct variable that I have in here is time of day that contain hour, minute, and second. And I have a variable name. The variable name is class start, which is the struct type. So that's my struct variable, start time. I can also use ampersand in front of that variable. What about integers? I have a score of 100 integers, right? And I just say I want to print the address of that array. So what does it mean by printing the address of the array? Well, it means you're printing or you showing the starting address of the array. So do you need an ampersand? Can I just use the array names instead of saying the ampersand and for in front of the array name like what I do with all other variables, you know, integer, floating point, and the ampersand, right? What about this one? Line 36. I'm using ampersand. So this look like the correct way of printing an array. The beginning address of an array, right? Ampersand followed by array name. That's by definition. Or the ampersand operator tell you the starting address and array. That makes perfect sense. What about this one? So we're gonna run the code and then you can see. What about the address of the first element of the array? I'm using ampersand and I say I want to print the address of score index 0, which is the first element of the array. So do you expect to see the address of the first element of the array and the address of the array to be the same? Well, I will run the example and then you should make the observation. And in the meantime, try to think of, whether it makes sense to see these two numbers that should be the same or different. Now, how about I'm adding? I say score at 1. What does that mean? So what exactly that means is I am printing the address of the score index 1. So why? Should I say ampersand score index 1? Yes, I can do that. Of course, I can just use ampersand and score index 1 in this expression. That should look perfectly fine. But we want to do something different. How about I say, take the address score array and add 1 to it. So you may think, wow, I'm just adding 1 to the memory address of score. Well, in the slide, we just look at the slide, and the slide say when you're adding 1 to the score to a memory address of something, you are adding really 1 time the size of that memory address of that data type or array type. So when we print the value, you see that. What about using the dereference pointer on an array name plus or the increment by 1 or plus 1? You see that we are doing all kinds of interesting stuff, right? What about int pointer? Can we print the content of a pointer itself? Notice that I'm not using the ampersand in front of the integer pointer. And also line 41, I'm printing the address of the pointer. So what's the difference between these two? I hope you should have an answer for it because it is obvious. It should be obvious, right? What about we increment the pointer by 1 and then I print the pointer by 1? And the next few line of code also show you the way to display an address of a character variable because it's special. It's a little bit different from the rest of the data type. So let's run this code, build and run. All right, so let me arrange the code and the output so that I can point to the code and output at the same time so to make it easy to see. Size of an integer pointer, that is 4. Size of integer pointer, that is 4 bytes. So the integer pointer takes 4 bytes of memory storage. And then we also print the memory address location of age, of GPA, of the Boolean variable, of the string, of the struct variable. Now, let's pay close attention to the array variables and see what they look like. All right, I say this is the memory location of integer score using array name. So I'm using array name like here. I say I want to print the address of the array, but I don't have to use ampersand. I just use array name. It says this is the starting address of my array. By the way, this is hexadecimal numbers. That's why you see all of these numbers. This is not decimal because it's hexadecimal. It has the digit D, digit F, and so on. So it's not from 0 to 9. It contains from 0 to 9 and then followed by A, B, C, D, E, F. Now, what about the address of the score array, but I'm using the ampersand? You see right here, ampersand. We're here, no ampersand. Actually, these two things mean the same thing. So you can display an address of an array using ampersand in front of array name or just using array name. So by convention, the compiler look at these two notations and the compiler treat these two notation as the same. So either you say the address of the score or you just use the score, which is the array variable name by itself. It's the same thing. What about the address of the first element of the array? Well, it's the same thing, right? Because the first element array, that the starting is the starting address array. So it's the same number. All of these tell you the memory address is the same. Now, we say I want to print score plus 1. So actually, when the compiler see this, the compiler will say, oh, what you mean is I go and take the address of score and I'm adding 1 time the size of the integer, which is the score data type. So the starting address of the score is 18. Just look at the last 3 digits, 18. You're adding 4 to 18. That's 1C. So it this is hexadecimal number. The number 8, then if you add 1, it becomes 9. If you add another 1, it becomes 10. But 10 in decimal is letter A. And then you add 1 more, that becomes letter B. And then you add 1 more, that becomes letter C. So when you're adding 4 to 8, it becomes 12, right? But 12 in decimal is C in hexadecimal. And I can also use a dereference on an address of an array element. So you see that in the code up here, I assign the value of 10 to score index 1. And then I'm not using the index, but I say, give me the address of score plus 1, which is 1 after, which is the second element. And then I say dereference it. What you're getting is the value of the second element of the array. Int pointer, that's the starting address of array. You see, I just say cout int pointer, and that is the address of the starting of the array because I assign int pointer using the array name. So that means you'll get the address of the array assigned to me. So it's different from assign it to the primitive data type variable, a single element, you need to say ampersand in front. But with the array, you just use the array name. It will get the address. So that works correctly. And what about ampersand instead of a pointer name? So is there a difference between the pointer variable and ampersand in variable? You see the output? They are different. The int pointer contains the address of starting of the score array. The address of int pointer is a different location because int pointer itself is also a variable and it occupies some memory storage and the address is starting at that address. So that's why the address of int pointer is not the same as the int pointer itself. Now, let's see how we do arithmetic on a pointer. I just say int pointer plus plus. So basically, if int pointer is integer, you are incremented by 1, correct? But int pointer is not an integer. When you increment it, I already mentioned it, it's increment by 1 time the size of an integer. So you see, int pointer has a value of this hex digit. The last 2 digits are 1 and 8. Then I increment by 1, you see, it becomes 1 and C. So I told you 8 plus 4 is 12 and C is 12 in hexadecimal. So increment the pointer by 1 means you are incrementing by 1 time the size of whatever data it's pointing to. So 8 become 12. Now, let's take a look at how you display character variable. I have a character data type A, grade, I assign letter A, and I have a char pointer, which stands for character pointer, and I assign address of grade, right? Now, I want to display the content of the char of the char pointer or the address of the grade variable. The content of char pointer, I can just say char pointer. It should display the content of char variable. And also, I say that's the incorrect way. Or let's say I'm going to change the code and I use ampersand, and then we'll talk about the output. So let's say I'm going to say, I'm adding one more line right here. I'm going to say that's the incorrect way. So let's see what it shows. Okay, I'm going to copy, paste this exactly, exact code, except I'm going to use ampersand of the char variable. or in this case, that's my grade, right? So ampersand of grade. So you expect that the content of jar pointer and the address of grade should give you the same number. It should tell you the memory address of that character, correct? All right, let's run the code and see. Oops. Yeah, okay, I already saved. So what is this? Okay, so I'm gonna display, I'm gonna move this output window down here so you can see code and the output window at the same time. You see that I do a cout on jar pointer, and with other variable, you expect to see the memory address. But in here, for jar pointer, it display the content of the the memory location there, which is the letter grade A, and also followed by some junk, right? This is not really address of anything. And the same thing happened when we use address of jar. It also give us the character, which is what that's not what we expected, and also it looked like it's display some whatever data happened to be at that location near this character that we just declared, right? So that's why I say this is the incorrect way to display the memory because it doesn't just really display the memory address of the chart. The correct way is down here. So this look like an address like anything else that you see in the rest of this example. So what we have to say is take this, the content of this variable and do a casting. Casting means you take the content of the variable and then you say this variable point to a data type void. But basically that pointer variable really contain the address of a char. But the char is really a special variable data type in C++ because when you do cout char, it just type it just print the content of the char. So it's handled differently from the rest of the data type. Therefore, if you just print the char and you expect to see, using the same logic that you're using for array of integers, that will not work. Okay, so that's one example. Another example I want to point out is the index address. So let's take a look at this code and see what's abnormal or what doesn't look correct about this example. So I have an array, 10 array of 10 integers, and then I have an x pointer variable. I assign the array name to it. And I already talked about it a few minutes ago. That means you take the address, starting address array you assign to this pointer. That should work fine. Now, I want to print the second element of this array. Oh, actually the third element because index 2 is the second element, but you start counting from 0, right? So you should expect to see this number. This is perfectly correct. Makes sense, right? Now, can I use a different notation? Or can instead of say x index 2, can I do 2 index x? What do you think? I give you a minute to think about it. And then how about I take x pointer, I plus 2, and then I dereference it. So if you use the same logic like the other example, you should be able to figure out this one. Thus, you may have problems trying to figure it out, right? Because it doesn't look like the right syntax at all. It's like I can do X index 2, but how do I do 2 index X? That doesn't make sense, right? Okay, and then more example down here. I have a string A, so this is obviously an array of string. How many elements I have in this array? It's obvious I have 2. This is one string, this is the second string. So there are 2 strings in this array A, right? And I'm doing the same thing. Print in A index 0 and print in 1 index A. Is that strange, or do you think this will work, or is that a syntax error? You know, the only way to find out is to compile, run it. Compile, run. All right, that's the output. Now you see it's a x index 2 is 68, which is obvious, right? Let me use some annotation to show. You see, x index 2 is 68. That is from here. That is perfectly correct. What about 2 index x? It's also give you 68. That's the same element. So you can switch the position of these two. Is that interesting? And this is also has the value of 68. So all of these 3 expressions access the same element of the array. Okay, so I also want to show you the next input, and I will explain how it works. A index 0. That's obvious, right? It should print this string. A index 0. This one is simple. That's the output. What about 1 index A? It's say 1 index A. Do you think this will work? This is really the second element of my string A array. Now, is that something weird? How can this be correct? Well, the explanation, let me go with a very basic explanation that you learned from Algebra 2. What is this Algebra 2 explanation? It's called commutative property. Do you remember in Algebra 2, commutative property mean you take x plus y, it should be the same result as y plus x. You just exchange the position of these two variables. X plus y equal y plus x. That's really simple, straightforward, right? Now, how do we use the same commutative property in this array index? So if you think about array A index 0 is the address of A plus 0. Because you know the first element of the array is the starting address of the array, and index A plus 0, that makes perfect sense, right? Array index 0 is an array of address of A plus 0 offset into array. What about A index 1? Well, you can write A index 1 as the address of A plus 1. So this is exactly the same as the line above, right? Now, we say we apply the commutative property of addition. So we revise this, instead of say x plus y, we say y plus x. So we say, how about we write a different way? That means we can write 1 plus address of A. So that's translated to index. I can say I write 1 right here, and then I say address of A is the array A, right? So that's exactly what this tell you. Just commutative property of addition, right? Is that convincing enough? Is that good reason why you can do this? Yes, you can do this, but the code is not that straightforward, it's not readable. So how the compiler figure it out? The compiler doesn't know commutative property, right? Well, the compiler figure out by doing this. So whenever you have this expression, an array with an index, what the compiler does is compiler will say, let me go and figure out where that element is by taking the address of x plus the index multiplied by the size of my data type. So that's what the compiler does. So when you write x index 2 or 2 index x, the compiler does exactly the same thing. So that's why it works perfectly fine even if you write the expression in the reverse order, because the compiler just say, I will do whatever, now I take the array. I'm just calculating what we call effective uh, memory address. So just taking array address and add the number, the multiply by the size of that data type. Isn't that interesting? A lot of people think that you cannot use array index using an integer and then you do an array as an index. It means exactly the same thing. So anyway, that's the end of this video. See you in the next video.